Alrighty guys, this is perfect square trinomials and difference of squares. This is for Friday, February 10th. Alrighty, so there's 3 problems up here at the top, and you should notice that they look similar to questions that we've already been doing, and that's because that they are. The only thing different that we're going to notice is that when we factor them, something interesting is going to happen. So let's just hop right in. Okay, so these are called perfect square trinomials. So when I draw my x, I see here a is 1, b is negative 14, and c is 49. So on top I have 49, and down here I have negative 14. Okay, so I'm trying to find 2 numbers that multiply to 49 and add to negative 14. They're both going to need to be negative because they multiply to a positive and combine to a negative. So it's going to be negative 7 and negative 7. So I'm breaking up my middle term here into negative 7x and negative 7x. All right, so I'm going to bring down my x squared, and I'm going to bring down my positive 49. All right, just like normal from here, we're trying to find a GCF for the first binomial and for the second binomial. I notice the first binomial has x's in common, so I'm going to factor out an x. So I should be left with x minus 7. And then over here, I see a 7 and a 49. Well, I know 7 goes into 49. I just did that in my x factor. Also, I noticed looking at my signs, this negative here, I need to factor that out. Okay, I'm trying to get a positive x, minus 7. In order to get a negative on this side, I need to factor out a negative. So I'm factoring out negative 7. Okay, so when I do that, I should get x minus 7. Okay, so what we should notice, first off, is that what's inside our parentheses is the same. Okay, and so that's going to leave us with x minus 7. And then also what I'm left with is x and negative 7. X minus 7. Okay, so this is called a perfect square trinomial because the same thing is being multiplied by itself. Now, the way to write this is, remember, if something's being multiplied by itself, that means it's being squared. So we can take this one step further and write this as x minus 7 squared. All right, so that's just one extra little step, I guess you could call it, for these types of problems, is where we take that number and then, sorry, I blanked. Okay, we take that binomial and then make it squared. Okay, all right, so we can do another problem. Let's take a look at this one. First thing I'm going to notice is that I am going to have a GCF. 3, 24, and 48 are all divisible by 3. So I'm going to factor 3 out from here. When I do that, I'm left with y squared plus 8y plus 48 divided by 3. If you're not sure, you could do a little division. 3 goes into 4 one time. 3 goes into 18 6 times. So that's going to be 16. Okay. Now, when I make my x factor, a times c is 16 and b is 8. All right, with perfect square trinomials, the 2 numbers that we find actually end up being the same. Notice the last one was negative 7 and negative 7. This one is 4 times 4. All right, so we're going to break this up, 4y and 4y. We do not want to forget this 3, right? The 3 stays on the outside there. Okay, we're bringing that down all the way with us. So I need to find my 2 GCFs. All right, so I have 3. My first GCF is going to be a y, so I have y plus 4. My second GCF is going to be a 4. When I divide that out, I have y plus 4. So again, we should see what's inside matches, y plus 4, but also what's outside also matches. So if I write this all together, I have 3, y plus 4, y plus 4. And I can rewrite this. Anything times itself is squared. So 3 times y plus 4 squared. All right. So that is perfect square trinomials. All right, now we're going to move on to difference of squares. Number 1, first make sure you actually have a difference of squares. Remember, difference means subtract. Right, difference means subtract. So as it says here, it must be a subtraction sign. And you have to be able to square root both terms. We're going to use the following rule to factor. So difference of squares means A and B are going to be square roots, I guess. We haven't really gone over square roots, but our answer is going to look like this: A minus B and A plus B. Okay? A squared and B squared are both going to be perfect squares, which you should have little handouts of. I wanted to go over the perfect squares real quick. So 1 squared is 1, 2 squared is 4, and these are all numbers that we are going to need to be able to recognize. 1, 4, 9, 16, 25, 6 squared is 36, 7 squared is 49, 8 squared 64, 9 squared is 81, 10 squared is 100. All right, these are all numbers that we need to be able to recognize as perfect squares. Okay, so when I'm factoring this, first thing I notice is that there's only 2 terms instead of 3, just a squared and negative 4. The second thing I'm looking for is that it's a difference or subtraction, okay, which this one is. I like to think of this as a squared breaks up into a times a, right? A times a is a squared. Negative 4 breaks up into, put a little dot there, 2 and negative 2. Okay, so we're going to take these and turn it into 2 binomials, a plus 2 and a minus 2. Okay, so when I write this, a plus 2 is my first binomial, a minus 2 is my second binomial. And that's it. Okay, we could check this by multiplying it out. If I multiply this out, I'd have a squared and minus 4. Okay, how about number 2? Well, 64 is a big number, and we need to recognize that it's a perfect square. 64 is 8 times 8, right? So here, n squared is n times n. This negative 64 is a perfect square. I know it's 8 times negative 8. Okay, gives me negative 64. Well, I'm going to pair them up, n times 8 and n times negative 8. Sorry, not times. N plus 8 times n minus 8. Okay, n plus 8, n minus 8. So n plus 8 times n minus 8. All right, so this is like a little shortcut. It's like a little trick. Okay. The next one we have here, 81 minus x squared. Well, this one looks a little bit different because the x, the variable, came second, right? That's okay. 81 is 9 times 9. And negative x squared is x times negative x, right? So let's pair them up. I'm going to have 9 plus x and 9 minus x. So notice it looks similar. Let me zoom out. It looks similar, but now the number is first and the variable is second. Okay. What about number 4? Can we factor number 4? K squared, that's something being squared, right? 25, we know 25 is 5 squared. But remember, it has to be difference. This right here, the plus in between, tells us this can't be factored. Okay, when something can't be factored, we call that prime. Prime means not factorable. So whenever it looks like a difference of squares, but it's a plus, it's a sum of squares, it's prime. It's not factorable. Okay? Let's look at some more. Okay, number 5. We haven't really seen one like this. We have a number in front of the x squared. Well, I know that 25 is 5 times 5. X squared is x times x. So if I break that apart, this is 5x times 5x, right? 49 is a perfect square. It's 7 times 7. This is negative 49. So I know that's 7 times negative 7. All right, now we're going to pair them up. So it's going to be 5x plus 7 times 5x minus 7. Oops, hit something. Okay. Looking at 6, just like before, the first thing we should look for is a GCF. 2 is not a perfect square. 72 is not a perfect square. This looks like, it looks like a difference of squares, right? But those two numbers throw me off. Well, I know 2 goes into both of them. So first thing I'm going to do is factor out this 2. So that means I'm dividing everything by 2. So I'm left with n squared, and then 72 over 2 is 36. Now I have a difference of squares. Just like before, we need to bring this 2 down with us. I know n squared is n times n, and negative 36 is 6 times negative 6. So we're going to pair them up. Bring that 2 down, right? Don't forget to bring the 2 down. So I have 2 n plus 6 times n minus 6. All right. Okay, looking at 7. 7 also kind of looks like a difference of squares. One thing I should notice is this plus. All right, it's not a difference, it's a sum. Even though it can't be factored as a difference of squares, if I look at my 18 and my 50, I see that I can factor something out of that, right? There's still a GCF. Off the top of my head, literally off the top of my head, I haven't actually looked at this yet. Off the top of my head, I can think of 2. Okay, I'm pretty sure that's the GCF of 18 and 50. Let me think, because 18, if you're not sure, list out the factors. 18's factors are 1, 2, 3, 6, 9, and 18, right? So I'm trying to figure out, which of these go into 50? And out of these, 2 is the only one. So I'm going to factor out a 2. Okay, so 18 divided by 2 is 9x squared. And then I have 50 over 2 is 25. Now it really looks like a difference of squares. 9 is a perfect square, 25 is a perfect square, but because of this plus in the middle, I can't go any further. Okay, this is a sum of squares. All right, so that is it. Okay. Lastly is number 8. Number 8, a 36 and a 9. 9 goes into 36, and they both have a p. So we definitely want to factor out our GCF first. On this one, I can see my GCF is 9p. So I'm going to divide everything by 9p, see what I have left in my parentheses, and maybe I can keep factoring. Okay, 36 over 9 is 4. P to the power of 3 divided by p to the power of 1 is p squared. Remember, 3 times 1. 9p over 9p is just 1. All right, let's look at our numbers. 4 and 1, both perfect squares, right? If we go back to our list of my perfect squares, 1 is 1 times 1, 4 is 2 times 2. So I can break this up. 4p squared is 2p times 2p, right? 2p times 2p. And negative 1 is 1 times negative 1. So I'm going to pair them up. Don't forget to bring that 9p all the way down. I have 2p plus 1 and 2p minus 1. Okay, so that is perfect square trinomials and difference of squares.